Hello, hi everyone. My name is Nehel and welcome to OneClass's stream. Today we'll be covering a few math questions. These questions have been popularly asked on our website and mostly range from the high school to university, college level questions. Just a little bit about myself. So I'm a University of Waterloo graduate. I went there to study mechanical engineering. I graduated in 2018 and since then, I've been working in the plastics industry as a project engineer. I recently decided that I would want to do a master's degree, so I'm starting my master's in mechanical engineering as well from the University of Toronto in January. So, really looking forward to that. All right, without further ado, let's get into some math questions. Let's do it. Okay, so the question one for today is find a quadratic model for the set of values, and we're given 3 points. So let's just call them point A, which is minus 2, 20, B, which is 0, negative 4, and C, which is 4, negative 20. Okay, so given these 3 points, we need to first recall what the standard formula for a quadratic equation is. So the standard formula for a quadratic equation is y is equals to ax squared plus bx plus c. So we need to be able to write these points in standard quadratic equation, which we have written down here. We would need to find the values of a, b, and c, which are constants. In order to do that, given the points which are the solutions to this quadratic equation, we can determine the 3 values. So let's start by plugging in those values to help us get the values of a, b, and c. So we will start by point B, by plugging in point B. The main reason for that is since x is equal to 0, that would help us right at the back get the value of the constant c, because when we plug in x equal to 0, these two terms would become 0 and we would get the value of c right away. So let me just try and explain to you what I'm doing. So step 1 would be plug in the values of the given points into the quadratic equation to solve for constants a, b, c. So these are small a, small b, and small c, which are part of the quadratic equation. So start with point B. Point B, which is 0, minus 4. So what this means is for B, x equals to 0 and y is equals to minus 4. Okay, so if I plug it in, we would get minus 4 is equals to a times 0 squared plus b times 0 plus c. So I plugged in those values in the quadratic equation. This obviously becomes 0. This is also 0. We are left with c. So therefore we get right at the back c equal to negative 4. Now that we've solved for one value, we can plug in the other two and get two equations to solve for a and b. So now we will plug in a, which is negative 2, negative 20, which means the x value for this is negative 2, y value for this is negative 20. So when I plug it in here, I would get negative 20 is equals to a times negative 2 squared plus b times negative 2 plus c. C is equal to minus 4, so that's minus 4. Taking the minus 4 to the other side, it becomes plus 4, and we get negative 16 is equals to 4a minus 2b. So that's our first equation which we got in terms of a and b. When we plug in the value of b, which is point c, we've already used point b. So when we plug in the value of point c, which is negative, or it's positive 4 comma negative 20, which means x is equals to 4 and y is equals to negative 20, we get y becomes negative 20, which is on the left hand side, is equals to a 4 squared plus b times 4 minus c, which is 4, negative 4. So negative 4 again goes on the other side and we get negative 16 is equals to 16a plus 4b. So this becomes our second equation. And so now to be able to solve for a and b, we should recall that if we're given two equations which are in two terms, I need to eliminate one of the variables in order to be able to solve for the other variable. So the way I would do that is I see right at the back that in this equation I have negative 2b and in the other one I have positive 4b. So if I multiply equation 1 by 2 on the left hand side and right hand side, what do I get? So 2 multiplied by, this is not equation 2, this is the number 2 multiplied by the equation 1, we get negative 32 is equals to 8a minus 4b. Now if I add equation 2 to this, what would I get? Plus equation, I'm adding equation 2. So the way you add an equation to another equation is the left hand side gets added to the left hand side and the right hand side gets added to the right hand side. Therefore, this becomes negative 32 minus 16 is equals to 16a plus 8a. Let me write the 8 better. Minus 4b plus 4b. So this way the 4b's gets cancelled. On the left hand side we get negative 32 minus negative 16, which is negative 48, and then on the right hand side we're left with 24a. So now if we solve for a, therefore a is equals to negative 48 divided by 24, which is equal to negative 2. So now we have the value of a, we have the value of c, we just need to get the value of b. So the way we get the value of b is we can plug the value of a into any of the two equations, 1 or 2, and we will be able to get it. So let's plug it into 1. So equation 1 was negative 16 is equals to 4 times a minus 2 times b. Let me just make sure, 4 times a minus 2 times b. So we know our a is equal to minus 2, so therefore it becomes negative 16 is equals to 4 times minus 2 is minus a minus 2b. We take the 8 to the other side, the negative 8, it becomes positive 8, and we get negative 8 is equals to negative 2b. Therefore b is equals to 4. So we get the value of b as well. Okay, so now since we have the value of a, b and c, we can round up the question. C is negative 4, b is positive 4, and a is negative 2. Therefore our quadratic equation becomes y is equals to a, which is negative 2 x squared, plus b x, so b is 4 x plus c, and c was equal to minus 4. C was equal to minus 4, yeah. So minus 4. If you want, you can solve it even further just to make it look better. If you take 2 common, you would get minus x squared plus 2x minus 2. But again, up till here is also a correct solution. Okay, so just to quickly recap, what we did in this question was we were given 3 points. We used each of those points to solve for the constants in our generic quadratic equation, which is y equals to ax squared plus bx plus c. Once we got the 3 constants, we can plug them back into the generic quadratic equation to get the final value find the final expression of the equation. Okay, so let's verify if that's what they have gotten as well. C is equal to -4. Perfect. And then they make 2 equations. We get b equals to 4 and then a equals to -2. So therefore the final equation becomes -2x squared plus 4x minus 4. Awesome. The solution is correct. Alright, let's get into the next question. So question number 2 for today's class. What is the square root of 204? So the basic principle behind a square root is essentially we need to find a number which I would multiply with itself to get 204. So the way we would do that is through prime factorization of 204. So question 2 is, what is the square root of 204? So we would do prime factorization. So 204, we will first divide by 2 since that's the smallest prime number. So with 2 we get 102. Again we can divide this by 2. 2 we get 51. Now it's no longer divisible by 2, but if we see if this is divisible by 3, since the sum of the numbers is equal to 6, which is divisible by 3. So we would say 3, and that's equal to, I believe, 17. Okay, and then 17 is no longer divisible. So what that means is our prime factors for 204 are these numbers here. So we can write under root of 204 to be, or square root of 204 is equals to square root of 2 times 2 times 3 times 17, which is equals to under root of 2 squared times 3 times 17 we know as 51. Since we have the square of 2 inside the square root, and we know that under root of a square is nothing but a, we can say that this becomes, the 2 can come out of the square root and we would be left with under root of 51. Now this is the solution in the radical form. What I mean by that is this under root can no longer be further solved through prime factorization. So we can, if we wanted to compute this, we'll have to use the calculator. Okay, let's verify if that's the correct solution as well. So 204 is 4 times 51. Since 4 is a perfect rule, thus. Okay. So yeah, the answer is correct. Perfect. Let's get on with question number 3 for today. So in this question we have to prove y is log of a minus log of b equal to log of a over b. Okay. So question 3, ln a minus ln b equal to ln of a over b. So just to recall what logarithmic is and how it works, if I'm given the log of x equals to y, this is equivalent to e to the y is equals to x. So the logarithmic term becomes the answer, and then the answer becomes the exponent. Okay, so this is the key principle we would need to know in order to prove the above. Okay, so let's look at what ln a would look like. If ln a is equals to, ln is also the natural logarithm, which is to the base e. If logarithmic or ln a is equal to some value a, we don't need to know the value, it will be some numerical value. From this, applying this principle, we know that the y gets to the power and the x becomes the answer. So we would get e to the a is equals to small a. Similarly, we can say ln of b is equals to some value b, which would imply e to the b, capital B, is equals to small b, and there would also be some numerical value of the logarithmic term of the numbers a over b, and we can call that numerical value to be equal to c. From this, we would say, if we were to take the inverse of it, we would say e to the c is equals to a over b. Okay, so looking at the last term which we got, which was e to the c is equals to a over b, we know the values of a and b since we have gotten them in the first two parts of the solution. So we can substitute the value of small a and small b into this. So we would get from that e to the c is equals to e to the a, which is a, which is equal to e to the capital A. This is capital C, and b, which is equal to e to the capital B. Okay, so far so good. I hope you're following along. So the next step would be, if we remember the property of exponents. So let's say we have any number a to the power of n divided by the same number a to the power of m, we can say this equal to a to the power of n minus m. So that's the property of exponents, or exponential property. So we can apply this property to this equation here, and we would get e to the capital C is equals to e to the capital A minus b. Okay, if I were to take the logarithmic of either side, which is saying I would compute the log of e to the c and compute the log of e to the a minus b, I would get c is equals to a minus b. This is essentially because log of e to the a is equals to a. Okay, so since we have gotten this, which is kind of brought us to the final answer as well, since initially we defined c to be able to, or capital C equal to log of, or natural log of a over b, a to be equal to natural log of a, and then b to be equal to natural log of b. So from this we have come, or we've come full circle, you can say. So we started off with the two logarithmic terms and equating their value to some numerical value a and some numerical value b. From that we got the value of the small a's and small b's, and used that to go back into the logarithmic term through the help of random variable c. Okay, so this is how we were able to prove that this identity, which is division for logarithmic, actually holds true. Okay, so they have done a similar method. So ln becomes this, and then this becomes e to the a minus b. Perfect, perfect. Okay, next up. Okay, so question number 4. Find the value of the discriminant and determine the nature of the roots of the quadratic equation. So we're given a quadratic equation, negative 4r squared minus 4r is equals to 6. So first of all, don't get confused that why is it not in terms of x. The quadratic equation can be in any term, meaning the variable can be x, y, z, whatever. In this case, the variable is r. To make it look more like a quadratic equation, what we will do is we will take the 6 to the other side, or you can say we would subtract 6 from both sides, and we would get negative 4r squared minus 4r minus 6 is equals to 0. And then we would multiply the entire equation by negative 1, which would give us 4r squared plus 4r plus 6 is equals to 0. So this is the quadratic equation in hand, and what we have to do is we have to calculate the determinant of this. The good thing about the determinant is right off the back, if we calculate it, we will be able to estimate what the roots or the nature of the roots. So when I say the nature, I mean to say if the roots would be real or not, and how many roots would I have, if I would have one root, or if I would have two real roots, or if I have no real roots. So the determinant is represented by capital D, and it's equal to b squared minus 4ac. So now what is b squared, you'll be asking? So the generic quadratic equation is represented as a is equals to a, or y is equals to ax squared plus bx plus c. So in this case, we're given a to be 4, b to be 4, and c to be 6. So if I were to plug all of them in, for the determinant value, I would get 4 squared minus 4 times 4 times 6 is equals to 16 minus 16 times 6, which is 96. So the final value would be negative 80. So our determinant is actually negative. So now, in order to be able to identify what would be the nature of the roots, we need to know 3 properties of the determinants. So the 3 properties of the determinants are, first, if determinant is greater than 0, we can say that the quadratic equation has 2 distinct real roots. Second, if d is equal to 0, we can say that the quadratic equation has just 1 distinct real root. And lastly, if the determinant is less than 0, we will have to say that there are no real roots. In our case, since d is equal to negative 80, we would come to the conclusion that for the equation, let's see, what was the equation again? Yeah. So for the equation minus 4r squared plus 4r plus 6 equal to 0, we can say that there are no real roots. Okay, so the key takeaway from this question is we need to know the 3 properties of the determinants. We need to be able to solve for a, b, and c in the standard quadratic equation form. Using that, we need to be able to calculate the value of the determinant, and then from the value and the properties, we would know the nature of the roots or the solutions for the quadratic equation. Okay, so let's verify as well. So these are the three cases that has been presented: the equation A equal to 4, B equal to 4, and C equal to 6. And we get negative 80, and which is less than or equal to 0. Therefore, it has no real roots or solution. So the answer in this case is correct. Okay, let's get on with question number 5. The question 5 asks for how do you find the range of a function algebraically? And the function is y is equals to x plus 5 over x minus 5. So question 5, find the range of y is equals to x plus 5 over x minus 2. So first of all, what is the range? So the range of a function is all the values the function can take without it being non-real or non-solvable. In this case, the range of this function would be all the possible values of y. So we're trying to find all possible values that y can take. Okay. Similarly, even though this question does not ask for it, I will just briefly touch upon it. If we were to ask for the domain would be all possible values which x can take. So in this case, we're not being asked for it, but that's how you define the domain. So in this case, the way we would be able to find out all possible values for y is we would have to solve for x. So I'll show you how I would do that in just a second, but let's first solve for x. So the way we would do that is we would cross multiply the denominator with the left hand side is equals to x plus 5. So yx minus 2y is equals to x plus 5. This goes to the other side, x becomes common, x 1, sorry, x of y minus 1 minus 2y is equals to 5, x is equals to 5 plus 2y over y minus 1. Okay, so the way we solve for y is first we took the numerator or the denominator of the initial equation. So we took this and we cross multiplied it to the other side. After that, we opened the bracket and we solved for the final expression. After solving for that, we took the x to the other side, and when we took the negative 2 to the other side, once we took the x to the other side, we actually saw that we have the term yx and negative x on the same side. So we can extract x to be the common term from 2, and we are left with x times y minus 1. After that, the final step was to send y minus 1 back to the denominator on the right hand side. Okay, so now that we have solved for y in terms of x, we can say that just by looking at this, we know that x is defined for all values of y, but for y equal to 1. Because when y equals to 1, this term becomes 0, and any number divided by 0 is undefined, so that would be a problem. So we can say that y cannot be equal to 1. Okay, and that is the only number which would pose a problem. All of the numbers are part of the range, whereas y equal to 1 is not part of the range. Okay, so therefore the range of the function y is equals to x plus 5 over x minus 2 is, we have to be a bit careful with the notation here. So the way we express range is y belongs to a subset. The subset would be from negative infinity to 1, or sorry, negative 1. Actually, it'll be positive 1. Negative infinity to 1 union 1 to infinity. Okay, so y would belong to this subset. It's very important to note that the curly bracket, or the normal bracket in this case, represents not included. If it was a square bracket, we would say included. So since we have used a normal bracket, it means that 1 is not included in the range. Therefore, y belongs to a range negative infinity to 1 union 1 to infinity, positive infinity. Okay, let's verify the solution. To find the range, we must be able to algebraically inverse the function, and we get this, which is perfect. We got that as well. In this expression, the value of x becomes undefined when y equals to 1, but they perfect. Okay. Okay. Question number 6. What is the constant of proportionality? So two things are said to be proportional when one term increases, the other term increases as well, or when one term decreases, the other term decreases as well. So for example, question 6. So for example, if we have two variables x and y, and then when x increases, y also increases, or when x decreases, y also decreases. If two variables share such a relationship, we can call them to be proportional. There might be cases when x increases, y decreases, so it's an opposite effect. In that case, we call them inversely proportional. But in this case, they are called proportional. And if we were to take the ratios of the two terms, so if we were to take the ratio of y over x, we would get a constant equal to k. K is defined as the constant of proportionality. So k is the constant of proportionality. If I were to give you a quick example of this, is when we apply a force to a spring, so when we apply a force to a spring F, the spring moves by some distance, or the spring displaces by some distance x. because of the force. Now this distance x we know is the displacement and the restoring force. So when we press a spring, it wants to push back, so it has some restoring force. The restoring force for the spring from Hooke's law is given by F restore is equal to K times X, where K is the constant of proportionality and X is the displacement. So K is actually a physical property of the spring, but it's also the constant of proportionality. So the answer to this question is when you have two variables which change with respect to each other and you take the ratio of the two variables, you get the constant of proportionality. Perfect. Yeah, this answer is correct. Okay, so next question, what is y plus x cube? Or x plus 3 cube, sorry. I just read a completely different question. Question 7, x plus 3 whole cube. So the easiest way to solve the question is if you know the identity of x plus or a plus b whole cube. So the identity is a plus b whole cube is equals to a square plus b square plus 3a squared b plus 3ab squared. Okay. The other way of doing it is you multiply them manually, which is you have this can be written as x plus 3 times x plus 3 times x plus 3, and then you can use the FOIL method, which is first, outer, inner, left, and you multiply all of them individually. But it's much easier to remember this identity, and that way you can solve for all cube roots. So we're going to use this identity here. In the question, a is equals to x and b is equals to 3. Therefore, the expression becomes x plus 3 whole square is equals to a square, which is x square, plus b square, which is 3 square, plus 3a square, which is 3x square b, which is times 3, plus 3x b square, which is 3 square. So if we further simplify this expression, we get x square plus 3 square, which is equal to 9, plus 9x square, and 3 square, which is 9 times 3 becomes 27, 27x. Okay, we can add the two 9x square or x square terms, and we would get 10x square plus 27x plus 9 as the overall square number or cube number. Okay, let's verify. Oh, I made a small mistake. So this equation is actually a cube plus b cube. So my apologies on the error, a cube plus b cube. So this becomes, and then 9 3's cube becomes 27. Okay, and then okay, you know what, let me just rewrite this. Yeah, I think I wrote the square there, so that's why I got confused. So this is actually equal to x cubed plus 3a cubed plus 3a is x squared b plus 3a, which is again x, and b is 3 squared. So we get is equals to x cubed plus 3 cubed is 27 plus 9x squared plus 3 squared, which is 9 times 3 is 27, so 27x. Therefore, the final answer in this case becomes x cubed plus 9x squared plus 27x plus 27. So in hindsight, maybe using the fall method, we would have avoided the mistake, but I would still suggest remember this identity: a plus b whole cube is equal to a cube plus b cube plus 3a square b plus 3ab square, and we'll be able to get to the answer without a problem. Okay, so looks like the solution has used the fall method and they have gotten the same answer. So the answer is correct in this case. Okay. Question number 8. How would you simplify the ratio of factorials? So what is a factorial? Let's just quickly recap. So question 8. Factorial is nothing but the product of the number itself with all the numbers from that number leading up to 1. So basically, a factorial for number n would be equal to n times n minus 1 times n minus 2 all the way up to we get to the number 1. Okay, so just to give you an example, so for example, 4 factorial would be equal to 4 times 4 minus 1, 3 times 4 minus 2, 2 times 4 minus 3, 1. Okay, so this is basically equal to 24. Alright, so with that in mind, the question is asking for a simplification for this factorial. So we would say that n plus 1 factorial over n minus 1 factorial is equals to n plus 1 factorial could be written as nothing but n plus 1 times n plus 1 minus 1, which is n multiplied by n plus 1 minus 2, which is nothing but n minus 1 times n minus 2 all the way to 1. Okay, and on the denominator, let's not simplify it, let's just keep it as n minus 1 factorial. So now if you pay attention on the numerator, you have a few terms which look very similar to what would be said to be the factorial of n minus 1. The factorial of n minus 1 would be n minus 1 multiplied by n minus 2 multiplied by all the numbers up to 1. Therefore, we can say that this is nothing but n minus 1 factorial. Okay, so all these terms here cancel out with the term in the denominator. Therefore, the right hand side becomes nothing but equal to n plus 1 times n. So essentially the key takeaway from this question is, if you have a factorial of a number n and if you have the factorial of a smaller number divided by it, you can get rid of a lot of the numbers. So just a quick example. So if I have, let's say, factorial of 6 divided by factorial of 4, we can say this is equal to 6 times 5 times 4 factorial over 4 factorial. And then this would go away with this, and we would be left with 30. So it's easier to calculate it this way if you have a bigger numbers factorial divided by a smaller numbers factorial. Okay? Or it's equal to n squared plus n, which is the same thing. Okay. So this solution is correct in this case. Alright, question 9. So what is the domain and range of the function when we're given a function? Okay, so if you recall what the domain and range are, a domain is all the values which x can take, and the range is all the values the overall function, or in this case f of x, can take. So domain is all possible values of x, and range is defined as all possible values of f of x, or the function itself, range with an e. So in this case, if we look at the function 3x plus 5, there is no value of x which would make this function non-solvable. Therefore, what I mean by that is, no matter what value of x is given, we would always have an f of x. We're never getting a case where the number approaches to infinity, or we are dividing the number by 0. So there are no unsolvable cases. Therefore, what that means is the range and domain of the function f of x. So we would say domain is equals to x belonging to all real values, and range would also be equal to f of x, which belongs to all real values. So for no value of x are we getting a value of f of x where it does not exist. So it's a continuous function. So because the given function is a linear function, it graphs as a straight line that stretches with no bound, thus the domain and range of the function is set to all real numbers. Perfect. So the solution is correct. So question number 10. Solve for x squared minus 9x equal to 0. X squared minus 9x equal to 0. So just something which we can test out, even though this question in itself is fairly straightforward, is the determinant thing which we learned today. So we said the determinant is equals to b squared minus 4ac, and we have two distinct real roots if this is greater than 0. Okay, so in this case b is equal to 9, so we get 81 as b squared minus 4, and a is equal to 1 for ac, and c does not exist, c is 0. So 4a times 0 is equals to 81. So since the determinant is greater than 0, we know right at the back that we would have two distinct real roots for this equation. The way we would solve for this real roots is we can take x common from this equation. So we can say this is equal to x times x squared minus 9 equal to 0. Sorry, this would be x minus 9 equal to 0. Right, looking at this, there will be two ways that this multiplication can result to 0. The first one would be if this term is equal to 0. The second one would be if this term is equal to 0. Because if we multiply two terms and if we're getting 0, one of them has to be 0. So for the first case, we would have to have x is equals to 0. And for the second case, for that to be 0, we would have to have x minus 9 is equals to 0. Or we would have to have x is equals to 9. Okay, so therefore, the two solutions to the equation x squared minus 9x is equals to 0 are x is equals to 0 and x is equals to 9. Okay, so let's verify the answer as well. First, we factor x since it's common in both the terms, and then we set each of the factors equal to 0, and we would have 0 as 9 as the roots. Perfect. Alright, so this answer is correct as well. Let's go on to the next question. This is another factoring question. So we're given an equation x squared minus 2x plus 1. Okay, so again, if we wanted to check what the nature of the roots are, we can say that we can do that by calculating the determinant, which is equal to b squared minus 4ac, which would be equal to 2 squared minus 4a, which is equal to 1, and then c, which is also equal to 1. So we get 4 minus 4 is equals to 0, which means that we would only have one distinct real solution. Therefore, since b equal to 0, we will have one distinct real solution. Okay, so from that, it should give me the sense that I'm not going to get a product of two terms. I would have something which has only one solution, so it will likely be one term. Okay, keeping that in mind and looking again at the equation, this is very similar to the equation of form a squared plus b squared minus 2ab. If you look at a equal to x and b equal to 1, this completely matches it. And we know that this is nothing but equal to a minus b whole square. Okay, so this question, the easiest way to solve this is first you look at the determinant, second you look at if it resembles a given identity or not. So in this case it resembled the identity, so we can say that x squared minus 2x plus 1 is actually equal to nothing but x minus 1 whole square. Therefore, if we were asked for the roots, the root of the given equation would be x is equals to 1. So if we were to set this equal to 0, that will only be 0 for x equal to 1. Okay. So the question doesn't really ask for it, so we have just factored it and said x minus 1 whole squared is the solution. So this solution is correct. Okay. So we don't have too much time remaining, so I think we'll likely have to stop here for today, and we'll pick up from where we left off in the next class. So we covered about 12 questions in today's session. I hope it was useful. If you did find any use from this session, I would really appreciate if you could give us a like, hit the subscribe button, and if you have any personal homework related or school related questions, feel free to comment on this video and ask us. If you do at all need help with one-on-one tutoring, or if you have any questions at all, there's some description in the description box. Feel free to reach out to us. This has been Nehel Malhotra. Thank you very much for watching, and I hope you have a great day. Thank you. Bye-bye.